So today we will study about dielectrics. So dielectrics are insulators which transmit electrical effects such as electric field, electric force, electric potential, etc. That is, dielectrics are basically insulators but that can transmit electrical effects such as electric field, electric force, and electric potential, etc. Example of dielectrics are water, NH3, oxygen, etc. There are two major types of dielectrics. There are two major types of dielectrics. That is, dielectrics are classified into two. They are called polar dielectrics, polar dielectrics, and non-polar dielectrics. Non-polar dielectrics. So polar dielectrics. Polar dielectrics are molecules having net dipole moment. That is, molecules of polar dielectrics have a net dipole moment. And examples of polar dielectrics are H2O, HCl, NH3, etc. And what about nonpolar dielectrics? Nonpolar dielectrics are molecules having no dipole moment. That is, molecules of these substances have no dipole moment. That is, polar dielectrics have net dipole moment and non-polar dielectrics have no dipole moment. Example are oxygen, hydrogen, nitrogen, etc. So next we can study polarization. Polarization is when a dielectric substance is placed in an external electric field, a net dipole moment is developed in this substance. This phenomenon is called polarization. That is, when we place a dielectric substance in an external electric field, a net dipole moment is developed in the substance. So this phenomenon is called polarization. So polarization is measured as the dipole moment developed per unit volume of the substance. So this is the equation: polarization is equal to dipole moment per unit volume, and we can write P is equal to small p divided by volume. The small p is the dipole moment. So unit of polarization is, we have unit of dipole moment. Dipole moment P is equal to Q into distance between two charges, that is, Coulomb meter is the unit of dipole moment. So unit of polarization is Coulomb meter per unit of volume is meter cube. So the total unit of polarization is Coulomb per meter square. So now we can study electric susceptibility. Electric susceptibility. So electric susceptibility, we know that polarization is directly proportional to directly proportional to electric field. That is, we know that polarization is a phenomenon in which we are placing a dielectric substance in an external electric field and a net dipole moment is developed in that. So from this, it is very clear that the dipole moment developed or the polarization is directly proportional to the electric field. So we can write the polarization capital P is proportional to electric field, and To remove this proportionality, we can use a constant. That constant is called chi. P is equal to chi E, and this constant is called electric susceptibility. Electric susceptibility. So this constant is called electric susceptibility, and we can write chi is equal to P by E. That is, we can say that electric susceptibility is the ratio of polarization to electric field. So next we can find the unit of susceptibility. Unit of chi is, we have the unit of polarization. We have the unit of polarization coulomb per meter square. That is coulomb per meter square per unit of electric field, Newton per coulomb. So finally the unit of chi is coulomb square per Newton meter square.